Hello guys, welcome back to the channel. Today we are going to solve this Leetcode question, which is remove zero sum consecutive nodes from linked list, and it is medium question. And in this question we are basically given the head of the linked list, and we need to repeatedly delete consecutive sequences of nodes that sum to zero until there are no such sequences. Okay. After doing so, return the head of the final linked list. You may return any such answer. So basically, if you look at this example, we need to just keep on adding the elements, and if we see a sequence which sums to 0, suppose here if you see -3 plus 3, which is 0, right? So we can remove these two and we can remove 1, 2 and 1 as the answer, or we can also remove, if you observe carefully, 1 plus 2, which is 3, and 3 minus 3 is 0, right? So we can remove these 3 and we can remove 3 comma 1. So we just need to remove the consecutive nodes which are summing to 0, right? That's it. If you look at this example, we're having 1, 2, 3, minus 3, 1, 4, right? So what is the sequence which is giving 0? You cannot say something like 1, 2, and minus 3. It cannot be non-consecutive, right? They said it should be consecutive. So they must be adjacent to each other, right? So it can only be 3 minus 3. Right? We can remove this consecutive sequence, and we can return 1, 2, and 4, right? And if you look at this example, we have a sequence of 3 minus 3, we can remove these two, and we can also remove 2 minus 2, and we can only return 1, right? 1. So after looking at these examples, the idea that I got was what I'll do is, initially this is my head, right? This is my head. Uh, I'll just keep on going from left to right, and I'll just keep on adding the same thing. So initially my sum is 0. Initially my sum will be 0, right? So I'll start a PDA pointer here. Now what I'll do is I'll add my sum to the value of the node. So my sum will become 1, right? Now is my sum 0? It's not 0, right? So I'll go to the next node. So my PTR will come here, and my sum at this point will be 3, right? So we cannot. It is not 0, so we won't do anything, and we'll go to the next node. And when I come here, my sum is 3 minus 3, which is 0. So at this point, I kept on adding each and every node, and my sum became 0, right? So all these nodes till this point are summing to 0, right? Are summing to 0. So they asked us to remove the consecutive nodes which are summing to 0, right? So I can remove these three nodes, right? Because they're giving me a sum of 0. So what I'll do is I'll remove these three nodes and I'll again start from here. So this will be my PTR pointer. I'll again add my value to the sum. So my sum will be 0 plus 3. It should be 3. So since this is not 0, we won't do anything. And we'll again come here. And we'll again add it to our value. Our sum will become 4. So sum is not 0, right? So we don't do anything. So at the end, we'll just return 3 comma 1, which is our answer, right? So let's look at this example in order to get a clear idea. So let's look at this example, guys. And by looking at this, you can easily say that you can remove 3 and minus 3, right? So these two are the consecutive nodes which are summing to 0. So I can remove these two. But how are we going to do programmatically means? But before that, we need to identify one thing. Let's say we have a line. We just keep on adding the elements. Suppose my sum till this point is 10, and I have also added another x number of nodes. So from here to here, my sum is also 10, again 10. So what should be the value of x so that my addition till this point is 10, and my addition till this point till the entire point is also 10. So it can only be possible when this x value is 0, right? So 10 plus 0 is 10. So the same thing happens here. So it may let us go through this in order to in order to understand this. So initially, what I'll do is I'll create a some variable. Initially, it will be 0, and I'll add this value. my pointer pointing to the head node, right? So I will add this value. So my sum will become 1. Now my pointer comes here. My pointer is pointing to this. So when I come here, my sum will become 3, right? So it is not 0, so we are not going to do anything. And again, my pointer will come here, and my sum will become 6, right? So again, we're not going to do anything. And when my pointer comes here, my sum becomes 6 minus 3, which is 3, right? So if you observe carefully, sorry, if you observe carefully, my sum became 3. So from here to here, my sum is 3. And from here to here as well, my sum is again 3. So this means the sum from this node to this node, it should be 0, right? So the sum from first node to this node is 3. And again, the sum from here to here, again it's 3. It's 3, right? So this should only be possible when the sum from here to here is 0. So when I find a sum which is already occurring. So when I find a sum which is already occurring, so that means all the nodes in between these two values, these two sums, are giving me a sum of 0. So at this point, if I have the pointer to this node, then what I'll do is I'll take the next of this and I will point it to the next of the sum which I got again, the sum which I got, right, at this point. So I'll point the pointer of this next node to the pointer of this node, right? Then these two will be this link will be broken and we don't have these two nodes, right? So let's try to understand this with another example. So before that, what I'm going to do is I'm going to tell you how am I going to maintain the pointer of the node, right? So I need to get the pointer of this node in order to point this node to this, right? So in that case, I'll use a hash map. Right? I'll tell you why am I using hash map. So initially my pointer is here, right? Initially my sum is 1. So is my sum already occurring in the hash map? It's not occurring, right? So I'll store 1 is occurring at this node. Let's say the address of this node is A, right? And again, when I come here, my sum is 3, right? Sum is not already in the hash map. So I'll add 3 and let's say the address of this node is B, right? Again, I'll come here and my sum is 6. 6 is not occurring in the map, right? So I will add 6 and the address of this node is C. And when I come here, I see that my sum is 3 and 3 is already present in the hash map. So this 3 is already present at this point, right? At node B. So I'll get this, I'll get the address of this node and I'll point it to the next of the current node. This is how I'm going to do this. So let's try to understand this with the third example. So let's try to understand this example. Guys, in this example, we can see all the three cases that can be observed. So this is the pointer that points to my first node, which is head. PTR also points here, right? So initially my sum will be initially I'm sorry. Initially my sum is 0, right? So my pointer is pointing here initially to the head pointer, right? So initially when I move my pointer to the first node, my sum will become 1, right? So I'll check if my sum is 0 or not. If it's 0, then all the nodes till this point are giving me a sum of 0. So I'll just remove all the nodes, right? Since sum is not 0, I'll check is the sum present in this hash map or not. It's not present, right? So what I'll do is I'll put my sum and I'll keep the address of this node, which is A. Let's say A. Now my pointer will come here. My sum will become 3, right? Is the sum 0? It's not 0. So I'll check if 3 is present in the hash map or not. It's not, right? So I will add 3 and this is coming at node B. And again my pointer will come here and my sum will become 6. Sum is not 0 and it is also not present in the hash map. So it will become 6 comma C. And my pointer will come here and at this point we need to observe carefully. My sum will become 3, right? And 3 is already present in the hash map. Means 3 is already occurring at this point. So from this node to this node, these nodes are giving me a sum of 0, right? So we need to remove. So I'll check previously where is the sum 3 is occurring. 3 is occurring at node B, which is this, right? So what I'll do is I'll keep the next of the node B to this node. So let's suppose the B is my previous node, which is previous. I'll get this previous from the map, right? I'll say map dot get of sum, then I'll get the B. What I'll do is previous dot next. My previous dot next will become ptr dot next, right? Ptr dot next means I'm removing this link and I'm creating a new link from this node to this node, right? So this means we are just basically removing these nodes. We're basically removing these nodes, so we don't have these nodes in between. So what's the important thing is when we are removing these nodes, we also need to remove the some values we are getting, right? So we're having a sum of 6, right? We need to remove this sum as well because when we don't have these nodes, we also don't have these sum values, right? So initially I missed this step and I tried to code that and it gave me an error. So we need to remove this as well. So how am I going to do that is I'll just place a pointer here, let's say a temp pointer, and my sum will be 3 plus 3 is 6. So my temp pointer goes till the pointer ptr and removes all the sums which are encountering in between these nodes, right? So I'll have a sum of 6 and I'll remove this 6 from the hash map. I'll remove this 6 from the hash map and it will become like this, right? So again, I'll come here. My ptr will be this and I'll see what's my sum. My sum is the previous sum is 3, right? 3 minus 2, which is sum is 1. Sum is 1 and 1 is already occurring in the map. So I'll again need to remove the nodes, right? So I'll again get the previous. What's the previous? A, right? Which is this. So previous dot next equals to the ptr dot next. So I'm just adding this link and I'm breaking this link. So basically we're just removing these nodes. These nodes from the, we're basically removing all these nodes in between. All these nodes like this. So we'll be having a direct link from the first node to this node. So, and again my pointer will come here, right? My pointer will come here and what's the sum? Sum till this point is 1 and at this point my sum will become 0, right? When my sum becomes 0, I said we'll just move my head to the next pointer because all the nodes from the first node till this point are giving a sum of 0. So I'll just remove all these nodes. Oh, in the previous step what we need to do is we also need to remove 3, right? From the node. And at this point when we are moving our head to this point, we need to remove all the values from in the hash map because we're just removing all the nodes from here to here. So in our hash map we should not have any previous values, right? So I'll just empty the hash map, so it will become like this. So I'll again move my pointer from here to here. My pointer will come here, right? And my sum will be 0 plus 3, which is 3. And at the end my pointer will move here and at the end we'll just remove 3. Oh, we'll just return 3, which is the head of the node. So that's it guys, let's try to code this up. So what I'm gonna do is initially I'll take a map which stores the integer and list the address of the node. Map equals to new hash map, and what I'll do is I'll take a ptr which points to my head, not to my head, to the head of the linked list. And what I'll do is while my ptr is not equals to null, I'll take a some variable 0 and at every node I'll increase my sum value, right? Sum equals to sum plus ptr dot value. We'll check if my sum is equals to 0. when my sum becomes 0, I need to remove all these nodes, right? How can I remove all these nodes? I'll just place my head equals to ptr.next, which is head equals to ptr.next, and I also need to remove all the nodes from the map, right? Map.clear. That's it. And else if my map contains this sum, if the map contains this sum, then what I need to do is I need to get the previous node, right? So I'm going to get the previous node equals to map.get of sum. Right, what I need to do is previous.next equals to ptr.next. Before changing that, I also need to, I'll take a temporary pointer because I need to remove the in between sums from the map, right? So in order to remove all the in between sums, I need to take a pointer to the next node. Temp equals to previous.next, and now my previous.next equals to ptr.next because my this is my let's say Jim, this is my previous.next equals to, if my pointer is here, ptr.next. And now I'll start from and I'll take a temp sum equals to sum, and while my temp pointer is not equals to ptr, suppose if I start my temp pointer from here, I said right, there will be in between nodes. I need to remove these sums from the map. So I'll start my temp pointer from here and I'll go till my ptr, and I'll go till my ptr, and I'll remove all the in between sums. So I initialize with my initial sum with this sum. So my temp sum will be the same as this sum, and I'll keep on adding, and all the intermediate values I'll remove them from the map, right? Now my temp sum equals to temp sum plus temp dot value and map dot remove of temp sum, and my temp should move to next pointer, right? Temp dot next. And if my sum is also not equal to 0 and my map also does not contain the sum, then what I need to do is I need to add it to the map. Map dot put sum comma the current node, which is pointed by the ptr, right? At the end, I'll just move my pointer to the next node. At the end, I'll just return my head. Let's try to run this. Yeah, it's getting accepted, guys, and look at all the wrong submissions. And we're basically, we're just keeping track of the previous nodes so that we can remove the nodes in between. And we also need to make sure that we're removing them from the map as well. This is the most tricky part to identify. And let's look at the time and space complexity. The time complexity is we're basically looping through the entire linked list. And in the worst case, we're gonna end up removing each and every node, right? So in the worst case, we're gonna traverse 2n times, because one time for traversing from front to end, and the second time for removing the consecutive nodes, right? And what's the space complexity? Since we are using a hash map, we're going to store it. In the worst case, we're going to store order of n nodes, right? So that is it, guys, for this video. And if you find the video helpful, give it a thumbs up.